Welcome to RedPoint Data Management for Hadoop. This video is an introduction to the configuration and some of the initial concepts of RedPoint Data Management for Hadoop, and I'm going to walk you through configuration on a Hadoop cluster and some of the first simple data processing that you can do on Hadoop. So let's assume that you have a Hadoop cluster. We're not going to go through the setup of that. What I have is a Hortonworks HDP 2.0 cluster with 8 nodes. This is a fairly underpowered cluster. They're basically hand-me-down workstations that we cobbled together. They're all i5s with 16 gig of memory and 3 SATA hard disks. Any real production Hadoop cluster will probably be considerably more powerful than this. To configure data management on Hadoop, you start with the repository panel in the data management client. If you don't see that, go to View, Repository, and it'll pop up for you. Navigate down to Settings, and then Site under Settings, and find the Hadoop tab. It'll come up blank like this. Now we need to know two pieces of information from your system administrator. The first is your name node address, and this can be either an IP address or a DNS name, and we also need your resource manager address. And your Hadoop system administrator will be able to tell you both of these things. If you're running on Hortonworks, the default resource manager port is 8050. If you're running on Cloudera, it's 8032. Once again, ask your system administrator for these exact numbers. Once you've got this, commit these changes, click on something else, like the repository, and come back. This tells data management to save these changes, and now they'll be available for browsing the Hadoop cluster. Press the ... button. You'll see that it comes up and you're actually browsing the Hadoop HDFS file system now. What we're going to do is locate a temporary folder where data management will store its temporary files while it's doing its work, and we'll also locate several tarballs, TGZ files, that contain the RedPoint data management software that I've already copied up into HDFS. So the temporary folder, I'm going to choose RPDM temp. I've already created these folders. Normally you would have to make this yourself. You'd start at the Hadoop root and say enter name for a new file, but since I've already created these, I'll just select RPDM temp, and now we start looking for our modules. Now these you will have already downloaded from the RedPoint support site, and there are up to 4 modules that you can install. The server module is always required. This is the base software for RedPoint data management on Hadoop. I've already uploaded this to this RPDM folder, and so I'm just going to go choose the last version that I have loaded here. Similarly, the CAS module for address standardization, if you've downloaded that, choose that and install it. SERP for Canadian address standardization, and if you have the geocoder module, select that as well. At this point, when you commit, this will save all the changes, and it'll ask, do you want to initialize these on Hadoop? You can skip this step. If you do it now, it'll ensure that the local resources are already expanded and cached the first time you run a Hadoop project, and you won't have to wait for it. So we'll go ahead and do this now, and I'll pause the video and come back after it's done. Alright, once that's finished, we'll continue. That can take up to 10 minutes depending on how many modules you've selected and how large your cluster is, because Hadoop is expanding all of those tarballs onto the local node caches. At this point, your Hadoop system is set up and ready to go. We've already verified that it's communicating with HDFS because I have been browsing the HDFS file system. If we want to see that we can read and write files to HDFS, that's done with the normal data management file input and output tools. Let me take a very simple case. I'll use a generate sequence to create a sequence of numbers between 1 and 1,000. I'll write that to a CSV file in HDFS. I'll write it to this temporary folder. I'll call it numbers.csv. And at this point I can run this project just like I would run any data management projects. It's written the 1,000 numbers to this CSV file, and I can turn around in a different project, read those 1,000 numbers back in by browsing to that same file, clicking Analyze, and then attaching a viewer and making sure I can read data back out. And there it is. So this has gotten us through the very basics of reading and writing data into HDFS, but we still haven't actually done anything on the Hadoop cluster itself. To do that, we'll need data in the Hadoop cluster, and you can use these same file and input and output tools, just like you would in the regular file system, move data into HDFS. I'm going to start with a data file. This is a business firmographics file with 11 million records. And I will read this from our local file system and write it into HDFS using the DLD format. This is our internal compressed self-describing format. This is 11 million records. It's about a gigabyte compressed, and you'll see it loads very quickly. We're basically saturating our gigabit connection into the Hadoop cluster when we're loading this. And that's it. Once that's been loaded into the HDF cluster, I can turn around, browse this file system, find the file I just created, and read it in with the DLD input tool, and send it to a viewer to verify that that data has been successfully loaded. And there it is. Now we're actually ready to do something in the Hadoop cluster itself. And to do that, we've introduced one new construct in data management. So this is the only thing you need to start working in the Hadoop cluster in parallel. So suppose that we want to take this same file we just got, this business firmographics file, and run it in the Hadoop cluster in tasks in parallel. To do that, I go to this Parallel tab. This talks about how I'm allowed to split up records amongst the parallel tasks running on Hadoop. By default, this splitting is record, meaning that records don't need to be grouped any particular way, that any records can be sent to each task for processing. If I want to do something simple, like, say, filter out the null contacts, send them on to my output connector, and then view that on the outside of this parallel section. I run it, and it turns into this other mode. It's showing transforms running in Hadoop. So right now we're kind of waking up the Hadoop cluster. It's spun up a bunch of transforms, and when they've all finished, it will start reading that data into my viewer. So it just processed those 11 million records and sent all the blank ones to my viewer, all 1.9 million or so of them. And that's all there is to it. The only difference between running on Hadoop and running on your local server in data management is this parallel section. And you have to keep in mind how the records are actually split up. Some kinds of processing are going to require that the records be grouped a certain way. For example, if you're doing matching, you almost always need to group your records by some kind of segmentation or break key. And to do that, you go back to this Parallel tab on your input, choose Partition, and choose what you're partitioning by. In this case, I'll group by zip code. So I'm telling data management, split up this input file, but then regroup it, order it by zip code, and send groups of records to tasks such that all the records with the same zip code go to the same parallel task. And by doing so, I can guarantee that if I want to compare all the records in the same zip code, that they'll be grouped together into the same task. And I can also do things, now that I've grouped them by zip code, I can say, well, let's go ahead and summarize and just create a count of records by zip code. And we'll output that overall list to our output. Now you'll see there's an extra phase that happens in our parallel sections execution. It does a partition. This is the equivalent of the MapReduce shuffle, although we're not actually using MapReduce. Once the partition is finished, then it'll go to the transforms, and each transform is going to do that little summarization, and then I'll get my counts out into my data viewer when it's all done. Now you can see there's a certain amount of overhead just running things on Hadoop. This is inherent to how Hadoop works, that there's a kind of startup time. The counts I got back out, and as you can see, for every zip code I produced a count of records by zip code. And this was all done in parallel on the Hadoop cluster. That's it for this video. In other videos, we'll demonstrate how to process much more complex things, including things like matching, sentiment analysis, weblog analysis, and many others.